In this video, we're going to take a look at section 3.7, which is on solving systems of inequalities in two variables. A linear inequality of two variables is an inequality that can be written in the form y is greater than or equal to mx plus b, or with any of the other inequality symbols that we've seen. So less than or equal to, greater than or less than. So essentially, it's like the equation y equals mx plus b, but with an inequality symbol in place of the equal sign. And that's what we're going to look at first. So this is not a system of linear inequalities yet. This is just a single linear inequality with two variables. So let's talk about how to deal with those first. Then we're going to look at systems at the end. All right. So a solution to a linear inequality of two variables is any x comma y that, when plugged into the inequality, results in a true statement. So the first couple of problems you're going to have on the homework will ask you to do just this. They're going to give you an ordered pair and ask you if it's a solution to an inequality that they've provided. So for this particular problem, what we have is negative 5 comma 9 is our ordered pair. The inequality we're being given is 3x minus y equals negative 7. So we have 3x minus y equals negative 7. And we want to know if this ordered pair is a solution to that. So what we're going to do is plug these numbers in for x and y. So remember, the ordered pair, x goes first, y goes second. So x is equal to negative 5, y is equal to 9. We'll plug those numbers into this inequality. So we'll have 3 times negative 5 minus y, which is 9, equals negative 9. Why am I putting equal signs? Okay, man, I don't know. Probably should just start this video over, but I don't feel like it. I thought we had a pretty good start. So let me just fix my mistake. I apologize for that. I don't know why I was putting equals. Let me see. Can I switch it back? Okay, here we go. So let's change it back to a greater than here, because that's what should have been there, and a greater than here. So I apologize. I wasn't paying attention. So the inequality is 3x minus y is greater than negative 7. So we plug the numbers in. Everything else I said is fine. We plug in negative 5 for x, plug in 9 for y. And then we want to know, does this come out as a true statement? And all it needs to do to be true is for the left-hand side to be bigger than negative 7. It could be anything. It could be 5, it could be 100, it could be negative 6. Anything that's bigger than negative 7 will make this true. So let's see what we come up with here. So we will simplify. So we have 3 times negative 5, that's going to be negative 15, minus 9, greater than negative 7. And when we simplify this, we get negative 24 is greater than negative 7, which is actually false. So it didn't work out. Negative 24 is actually less than negative 7. So this was false. So our answer in this case is no. Negative 5 comma 9 is not a solution to this inequality. So for it to be a solution, we would need to get a true statement here instead. All right, so you have a couple problems like that on the homework, and that's how you handle those. What we're going to be wanting, though, is not to know if one particular point is a solution to an inequality. Eventually, we're going to want to know what all the solutions are to this inequality. So we need to find all of them. So let's talk about how we are going to do that. So to find all solutions to a linear inequality of two variables, first, if possible, solve the inequality for y. Now, this is not the only way to do these problems, but I think this is, I would say, keeping it simple. It might not be the easiest way either necessarily, but it's a nice simple process. Solve it for y first, then graph the inequality as if it were an equation. So we're going to graph it as a line because these are linear inequalities. So we'll get a linear equation to graph. And this linear equation we get in step 2, the graph we're getting, is the boundary to our solution set. So what we're going to find first is the boundary for it. And then we will shade in the solution set. And it'll either be above the line that we graph or below the line that we graph. Now the border itself, we have to make a decision whether the border should be with the solution set or if it should stand apart away from the solution set. And so we will use a dashed line to show that it is not part of the solution set, and a solid line to show when it is part of the solution set. And you'll know when to use which one, whether there's an equals to there or not. So if your inequality has an equals to, then you should graph your line as a solid line to show that it's being included with our solution set. And if there's no equals to, like we see here, we use a dashed line to show that the line is not part of the solution set. That way it stands apart from it. And then deciding which region to shade in, whether we should shade above the line or below the line, is also not too hard to figure out. If your inequality says y is greater than something, you will shade above the line that you graph. You want all the ordered pairs that are above the line. And you shade below if you have y is less than something. So whatever line you get, you want all the ordered pairs that are below that line. And so you'll shade in that entire region. All right, so let's take a look at an example. Sorry, I'm having trouble talking this evening. So here's an example here. Now step 1 is already done for me. The inequality is already solved for y. So I'm going to skip to step 2, which is let's graph this as if it were an equation. So we're going to graph y equals x plus 1. So graph this as if this were an equation instead of an inequality. To graph this line, you have to think back to the previous chapter when we learned about graphing lines. The quickest way is to use, especially if you have it solved for y, is to use the slope, which in this case is 1, and the y-intercept, which is 0, 1. So we'll start from this point, 0, 1. Right, and then the slope, we can think of that as 1 over 1. It tells me some directions to help me find a second point. The directions in this case are to go up 1 and to the right 1. So from this point here, we will go up 1 and to the right 1. So up 1 to the right 1 gets me right here. And that gives me 2 points, so now I can draw my line. But don't just do it out of habit here, because we have an extra consideration to think about, which is, do we want this line to be drawn as a solid line, or do we want to draw it as a dashed line? So if you just kind of do it out of habit, you're just going to draw a solid line because that's what we do in every other situation. But in this case, we have to think about it first. And because this doesn't have an equals to, there's no equals to here, we're going to graph this as a dashed line instead of a solid line. And so let me connect these 2 points with a dashed line. Let me see if I have a tool that will draw a straight line for me. I don't know if this does. Let me see I don't know what this is going to do, honestly. Okay, that did not do what I wanted it to do. Okay, it kind of does. Okay, but it kind of messed up my screen too, so I apologize for that. All right, let me see if I can move that. No, didn't let me move it. Undo that. And let me just undo that line there. So let me see if I can get it to draw the straight line where I want. Okay, yeah, that worked out pretty good. Except I want it to be a dash line. I don't know if I can customize it like that. Oh, I can actually. Oh, it's over here. Okay, this is awesome. Okay. Oh, but I have to customize it first. So let me see if this works. Okay, so let me try one more time. So I'll start from here. Oh, this is excellent. Okay. So we draw a dashed line. And I'll try to do another one going this way. Oh, it lets me extend it. Oh, this is a really handy tool. All right. And so there's my line. There's my graph. And it's a dashed line, as we indicated over here, as what we needed for our solution to be correct. And then the last step, step 3, is to decide, do we shade above or below this line to find our solution set? Because the line itself is not the solution that we're looking for. We're looking for all of the ordered pairs that would make this inequality true, and they will either exist above this boundary or below the boundary. And the way we decide is to look at the inequality symbol up here. We have a y is less than something, which means we should shade below the line. So we will shade below. And I'm going to try to use a different tool here to do the shading, because I think it'd be hard to do with just the pen tool. So I have a highlighter tool. Let me see if I can make it bigger. So we're going to shade, maybe yellow is not the best color. Let's do green. All right, we're going to shade below the line. So everywhere below this line that we just graphed are my solutions to the inequality. So if I pick any point in this shaded region here, it'll make this inequality true. So you could test it out if you wanted to. In fact, the other method that you could use here that I'm not mentioning is called the test point method, where you pick a point and you test it out to make sure it works. And if it works, you shade that region in. So a point that we could pick over here, for example, would be like, let's say this one right here. This is at 2 comma negative 3. So if I've selected the right region, then this point should be a solution to this inequality. So if we were to plug in negative 3 for y and 2 for x, this should come out as a true statement. And it indeed does, right? We get negative 3 is less than 3. That is true. And that'll be the case for every point in this region. Every point in this region would make this inequality true. All right, so sorry about the hiccups there with the technology, but I think that worked out pretty well. And I'm trying out a new software. This is the first time I've used this to record a video. Actually, this is the software I use when I'm lecturing face-to-face, but I've never tried to use the line drawing tool, because usually on the smartboard that we use, I can just kind of do it by hand. But on the computer, it's a little bit more difficult. Anyways, I'm digressing, so let's keep moving forward. Let's take a look at another example. All right, so this one's really pretty similar. In fact, I kind of feel like this is a bit redundant. So maybe this would be a good opportunity for you to try a problem before you see the answer. So if you will, pause the video, try to see if you can find the solution set to this inequality using the same process we used on the last example, and then resume the video to see if you got the right answer. All right, so again, step 1 is already done for us, so we can skip to step 2, which is we want to graph y equals x minus 4. All right, so we will graph this line using the slope, which is 1, and the y-intercept, which is 0 comma negative 4. Think of this slope as being 1 over 1, so again, it's up 1 to the right 1. Starting from 0 comma negative 4, which is right here, we go up 1 to the right 1. Gives me that second point there. Because there's no equals to here, we again will draw this as a dashed line. Okay, so let me try that again like we did last time. All right, so connecting those 2 points with a dashed line because there is no equals to. And then we decide if we should shade above or below this graph. This time, however, it's a little bit different than last time. We have y is greater than something, so we will shade above our line. So we will shade above, which is going to look like this. All right, so all the points above this line are solutions to this inequality. All right, so that hopefully was the answer that you came up with as well. All right, and again, you could test it out. You don't have to, but you could test it out by picking a point. A good point here would be 0, 0. Could have done that last time as well, but you plug in 0 for x. Whoops, I'm going the wrong way with the inequality symbol there. Let's try that again. 0 for y, and I said the letters backwards too, I apologize. Plug in 0 for y and 0 for x to test this point out, and we get 0 is greater than negative 4. That's true, which means we shaded in the right region. So that's a good way to double check your answer, and that could be especially useful when you are taking the test that's on paper. If you're taking my class, then you're going to be taking this test on paper, and you'll have to check your answer to make sure you have it right. And this would be a good way to check. You don't have to check it, but it's a good idea when you're taking a test. So anyways, I'm kind of rambling a little bit this evening. I apologize. This one's going to be a little bit more challenging. So this one, step 1, is not done for me. It is not solve for y. So if I want to use that method that we were just using, the first step is you have to get the inequality solved for y. So let's go ahead and do that first. I'll subtract the 2x to the other side to get started. I get 3y is less than or equal to 6 minus 2x. And then we divide by 3 on both sides. And remember, we did this before with equations, so it's going to work the same way here. That 3 has to divide into both of these terms. And so we're going to get y is less than or equal to 6 over 3 minus 2/3 x, or 2x over 3. I guess I should have just simplified this one right away as well. So we have y is less than or equal to, that should have just been 2 minus 2/3 x. All right, so that's step 1. All right, let me try doing that again. That's step 1 here. All right, step 2, maybe I won't write out the details this time, but I'm just going to do the step. Step 2 is to graph it as if it were an equation. So we're going to graph y equals 2 minus 2/3 x. And so to do that, we will use the slope, again, which is negative 2/3, and the y-intercept, which is 0, 2. So I'm going to plot the point 0, 2. The slope of negative 2/3 tells me to go down 2 and to the right 3. Down 2 to the right 3. I end up here at this point, so that would be another point on my line. And this time, we are going to graph this as a solid line. So I feel bad. I wasn't going to write it down, but now I feel bad about it. So down 2 to the right 3 is what we did there. All right. We're going to graph this one as a solid line because we have an equals to here. So this time the line will be a solid line instead of a dashed line. So make sure you make that correct choice when you're doing this on Math Excel or My Math Lab. If you're a different student taking a different course or whatever, maybe you're using My Math Lab, and they will have a graphing tool for you to do all this, but you do have to toggle between solid line and dashed line. So make sure you make the right choice there. So we're going to do a solid line this time. And let's just extend it this way and try to stay connected to those 2 points. All right. And then step 3 is to decide whether we should shade above or below this line. And you might look back here at the original inequality, but that's not the safest place to look. You actually want to look here after you've already solved it for y. Because something that can happen as you're solving it for y, if you divide by negative on both sides, the symbol will get flipped around the other way. And it's really based on this that you'll decide whether you should shade above or below. If it's y is greater than something, you shade above. If it's y is less than something, you shade below, which means you want to look here to make that decision. All right, so for this one, I'm trying to pick a different color here. Maybe I'll pick green. We have, well, it's not the best color, but we have y is greater than something. So we will shade, oh, I said the wrong word. What is wrong with me? We have y is less than something. So we will shade below this line. All right, so this is step 3. So we'll shade below. And so that would be this area right here. All right, so all these points below this line. Now on Math Excel, there's a paint bucket tool. So you don't have to sit there and color it in. You just click once in this region and it'll automatically fill that region in for you. All right. So hopefully I haven't misspoken too badly and you're able to follow what's going on and everything's making sense. All right. Because now we have a special case to talk about, which is this one here. Step 1, solve it for y. You can't solve this for y because there is no y variable in this case. So we're going to have to call an audible here. Since we can't actually carry out step 1, we're going to have to do this whole problem slightly differently. We're going to skip step 1 and just go straight to step 2 since I can't solve it for y. And we're just going to go to step 2, which is graph this as if it were an equation. So we're going to graph y, sorry, not y. We're going to graph x equals -5. And if you think back to chapter 2, remember this is a special kind of line. It is a vertical line that passes through -5 on the x-axis. And again, to get Math Excel to draw that line for you, you still have to pick 2 points. Just pick any 2 points where the x-coordinate's -5. So I'll pick -5 on the x-axis, that's -5, 0. And then I'm picking this point here, -5, 2. And that gives me 2 points, and then Math Excel will draw the line for you from there. But before you have it draw your line, you need to decide, should it be a solid line or a dashed line? And in this case, it will be a dashed line because there's no equals to here. So we're going to have it drawn as a dashed line. So when I use my line drawing tool, I'm going to switch it to dashed before I start drawing it. Oops. So and it's going to be a vertical line. I'll try to make it as vertical as I can. I went a little bit off the mark there, but so we have this vertical line here, and that's as far as it's going to let me draw it. All right, so we end up with a vertical line, which also messes up our step 3, because step 3 is either shade above or below your graph. You can't do that with a vertical line. You can't shade above it or below it. The only choice you can make with a vertical line is, do I shade to the left or do I shade to the right? So what do you think the case should be here? Should I shade to the left or to the right? If it's less than, if I'm looking for all the points where x is less than -5, that's going to be to the left of this line, where the x values on the x-axis are smaller than -5, right? Here's where it equals -5. To the left of it is where I find x coordinates that are smaller than -5. So I want all the points to the left of this vertical line. So that's where I'm going to shade in this time. All right. So if you solve it for y, The question is, do you shade above or below the line? If it's y is less than, you shade below. If it's y is greater than, you shade above. But if you can solve for x, then the question becomes, do I shade to the left or to the right? If it's x is less than, you shade to the left. If it's x is greater than, you shade to the right. Okay, let's take a look at another example here. Okay, sorry, it's not another example. Let's move on to a system of inequalities, which we haven't done yet. So all of these so far have been individual inequalities. Let's do a system of inequalities now. To solve a system of inequalities, graph all inequalities on the same Cartesian coordinate system, and there could be more than two, there could be 3 or 4 on some of them, and find where the solution sets overlap each other. So you're trying to find the region that satisfies all the inequalities in your system at the same time. And so you don't want to completely shade everything in for each individual inequality, but you want to take a note of, for this inequality, I would shade above. For this one, I would shade below. For this other one, I would shade above. And then find the region where you're doing all of those things at once. And usually it'll be kind of a small, well, I don't know, it depends on the situation. If you have like 4 inequalities, usually it's kind of the small region in the middle. But it could be anywhere. So you just have to try to find the region that satisfies all of them. So let's take a look at a couple of examples of this. So here we have y is greater than or equal to x. That's my first inequality. And we also have y is less than or equal to negative x plus 6. So let's go ahead and look at the first inequality. So we're going to graph both of these on the same Cartesian coordinate system. So we have y is greater than or equal to x. Step 1 is already done for me. Step 2, we're going to graph the equation y equals x. The y-intercept here is 0. It's 0, 0, which will be this point here. And the slope is 1, so I'm going to go up 1 to the right 1. I'm going to draw this as a solid line because there's an equals to here, so I'm going to stop writing out all these details, but I'll just point them out verbally. So it's going to be a solid line passing through those 2 points. So let me switch my line drawing tool back to a solid line. And so we'll draw a solid line going through those 2 points. And then I'm not going to actually shade it in, but I want to make a mental note of where I would shade in this situation, right? So if this was my only inequality, which direction would I shade to get the solution set to this inequality? Because it's greater than here, I would shade above. So I'm not actually going to shade in that entire region above it, but either make a mental note of it, or sometimes what I like to do is this. Draw little arrows to remind me that for this inequality, I'm actually wanting to shade above the line. And let's keep that in mind as we look at the second inequality. So for the second inequality, we have y is less than or equal to negative x plus 6. So first we want to solve it for y. That's already done. Second, we want to graph the equation y equals negative x plus 6. So the y-intercept here is 0, 6. So I'm going to start at 0, 6. The slope is negative 1. So that's a little bit different than what we've seen before. That's going to be negative 1 over 1, which means we go down 1 and to the right 1. So down 1 to the right 1, we get this point here. I'm going to connect these 2 points again with a solid line because we have an equals to here. So we're going to draw this as a solid line. So I'm going to draw a line passing through those 2 points, and it'll be a solid line. And I think you should be crossing at kind of a nice point like that. So I think that might be more accurate. Oops, I messed that one up, didn't I? All right, will it let me continue this? No, okay. Sorry, it looks kind of funny. I think I drew 2 different lines there, but it looks like a continuous line, so I'm just going to leave it. All right, and in this case, if this was the only inequality I had, which way would I want to shade relative to this line? Because I have a less than here, I want to shade below this line. So I draw little arrows to remind me that if this had been the only inequality that I had, I would be shading below this line to find all the solutions to that inequality. So to solve the system of inequalities, I'm looking for a region that satisfies both the blue inequality and the red inequality at the same time. So of these regions here, A, B, C, or D, which region do we find is satisfying both inequalities at the same time? And most students are pretty quick to point out it's region A. Right? In region A, we're above the first line but below the second line at the same time, which is satisfying both inequalities simultaneously. So we're going to shade in just region A. This region is where we find ordered pairs that satisfy both of these inequalities at the same time. All right. And that's where the two solution sets are overlapping. So that's my final answer. All right, let's take a look at another example. Graph the system of inequalities. Find the coordinates of any vertices formed. Vertices are where the lines are crossing each other. So we'll talk about how to do that after we get the solution set up. We'll talk about how to find the vertex or where they cross one another. So we'll do this the same way we did the last problem. We have x plus y is less than or equal to 7. That's our first inequality. Our second inequality, we have x minus y. Oh, I can't draw a y. X minus y is less than or equal to 8. So let's start with the first one. We'll just deal with one at a time. Don't feel overwhelmed trying to deal with both of them at the same time. That would be difficult. Just focus on this one. First step, solve it for y by subtracting x to the other side. We get y is less than or equal to 7 minus x. The second step is to graph this as an equation. So we're going to graph y equals 7 minus x. That means the y-intercept is 7, which is 0, 7, which is this point right here. The slope is negative 1, so we're going to go down 1 to the right 1, just like we did in the last example. I'm going to connect these 2 points with a straight line, and this time it will be a solid line because we have the equals to here. So we're going to draw this as a solid line. Let's see if I can do it right this time. And because we want to find the vertices, I really want to make sure this graph is as accurate as possible. I don't know if I'm going to do the best job here. So I think if I'm following the points right, I think it should look something like that. And I'll see if I can extend it further this way too. All right, so something like that. I'm a little bit off, I think, but I think that gives you a good idea of what that line looks like. Let's move on to the second inequality. So we have first step, solve it for y. So we'll subtract x from both sides. Let me write that again. It kind of got sloppy there. Subtract x from both sides, and we'll get negative y. So this is going to make a difference here. Negative y is less than or equal to 8 minus x. And then to solve it for y, we'll have to divide by negative 1 on both sides. And we're going to get, I guess we'll go back to blue here. We're going to get y on the left-hand side. On the right-hand side, we get 8 divided by negative 1, which is negative 8. And then we'll have negative x divided by negative 1, which will make it positive x. But the critical thing here is because we divided by a negative on both sides, we have to flip the inequality symbol around. So that's something we learned way back in chapter 1, but it still holds here. Whenever you're dealing with inequalities, if you divide by a negative on both sides, you have to flip the symbol around the other way. All right, so step 2 is to graph this as if it were an equation. So we're going to graph y equals negative 8 plus x. And so the y-intercept there is negative 8, which is going to be way down here. 0, negative 8. The slope is positive 1, which means we're going to go up 1 to the right 1 to get another point. And then we're going to connect those 2 points with a straight line because, again, we have an equals to here. So connect these 2 points with a straight line, and we end up getting this. So I think I'm handling that about right. Let's see, maybe no. Better move it. Oh, and I just made a new line. That's not good. All right. I think once I start a new line, it doesn't let me edit the old line. So I'm just going to leave it like that. The line should also extend a little bit further down and to the left. The arrow indicates that, but I would have liked to extend it a little bit further. And this is pretty close to where they should be intersecting, if I'm not mistaken. So, all right. And so we're not done with the system of inequalities yet, so I'm not worried about finding that point of intersection just yet. So don't forget to do this on the exam, because I will have students where they get to these problems and they draw their lines and then they leave it like how you see on the screen right now. And what you need to do is shade in a region, right? So this system of inequalities should have some region of points that satisfies both of them, and you want to identify that by shading it in. So if you don't shade anything in, you lose like 2 or 3 points on the problem because it shows you don't understand that's an important aspect of the problem. Not just graphing the lines, but finding the the solution set to the system by shading in the appropriate region. So going back to our inequalities here, we want to shade below the first line, right? Because we have y is less than below the first line, which was this line right here. So below this line, but above the second line. Now, if you thought it should be below both lines because they both have less than, you got to be careful about that. You don't want to look at the original inequality. You want to look at the inequality after you've solved it for y. And what happened in our course of solving this for y is that symbol got flipped around the other way. So now we actually we want the y values to be greater than the y coordinates on that line, which means we want the points that are above that line. So this was my second line right here. We want the points above this line. And where we find, how do I want to say this? The region where both of these are true at the same time is, again, this region right here, region A. It isn't always that answer, but the two examples I chose happen to have the same sort of answer, which is this region on the left-hand side here. So it's going to be this region right here. It could have been any of them, right? They could easily make it where it's the top region that you shade in or the bottom one. So be prepared for any particular region getting shaded in. But in this case, the region that satisfies both of these inequalities at the same time is this region to the left. The last thing we want to do is find where these lines intersect each other. And so sometimes you can eyeball it. You can just look at the graph and see, okay, these two lines are going to intersect at this point right here. And we can kind of guess what it is for this one, but it's not a nice number, right? It's not exactly on a nice whole number. It's kind of in between some numbers there. And so we should probably, instead of trying to guess at what it is, we should calculate it manually from the equation. So instead of trying to determine it visually from the graph, let's calculate it from the inequalities that we were given. And if you think back to section 3.1, when we introduced system of equations, the method that we talked about for solving system of equations in 3.1 was to graph. And you can find where these two lines, the solution set to, how do I want to say this? Sorry, I'm getting my words jumbled up. You can find the solution to the system of equations by looking for where the lines intersect each other. That's what we learned in 3.1. So if we wanted to solve a system of equations, we could graph and find where the lines intersect each other. But the reverse is also true. If you want to find where two lines intersect each other, all you have to do is solve them as a system of equations. So if I want to find this point of intersection, take the equation for these two lines, solve it as a system of equations, and the solution you get is where these two lines are intersecting each other. So I'm going to solve this as a system of equations. I'm going to take x plus y, I'm sorry, I said equation, so let me follow through with that, equals 7, and x minus y equals 8. Right, so those are the two equations that correspond to these two lines. By solving that system of equations, I can find where these two lines cross each other. And it's a pretty easy system to solve. You can just do the elimination method. So I'm going to add the two equations together. I'll get x plus x, which is 2x, y minus y, the y's cancel out, and on the right-hand side I get 7 plus 8, which is 15. Solve that for x by dividing 2 on both sides, and you get x is equal to 15 halves. So that's the x coordinate, which in decimal form is 7.5, but MathXL probably would prefer that you type it in as a fraction, so we'll keep it as 15 halves, which looks about where it should be, right? It looks like it's between 7 and 8 if you look closely at it. Now we need to find the corresponding y value, so we'll take x equals 15 halves, plug it back into this equation here. We get 15 halves, sorry about that, plus y equals 7. Then we solve that for y by subtracting the 15 halves to the other side. We got to get a common denominator there, which will be 2. So that's going to give me 14 halves minus 15 halves. I'm sorry, I'm making a mess of things here. But we're going to get y is equal to negative 1/2. All right, and so we get x is 15 halves, y is negative 1/2. So where these two lines cross each other, where these two lines cross each other is at 15 halves, comma, negative 1/2. So we calculated it precisely instead of trying to get it by looking at the graph. All right, but if you have a graph where they cross each other in a really obvious way, where you can tell what that point is, you can just read it off the graph and that's fine. You don't have to do this every time. I would only recommend doing this if the point of intersection is not easily determined by just looking at it. Okay, I have one more example here. So this one's going to get a little bit extreme. We have multiple inequalities here for us to deal with. So not just two, but more than two. What we're going to do is go through each of them one by one, graph them on the same Cartesian coordinate system, which I didn't give myself here. So I'm going to have to draw my own. So this could get kind of messy. See, okay, that's not too bad, I guess. So I'll try to draw it by hand, but it's not going to look too good. All right. And so we're going to deal with these one at a time. So we have x plus 2y, is less than or equal to 14. And this is really worst case scenario. So if you can do this one, you're good to go. You can handle any problem I might give you on the test, because I'm not going to give you one quite this extreme on the exam. And this one's going to involve us having to solve for y. So this is just all the worst stuff possible happening all at once. So we'll solve this one for y by subtracting x to the other side. And we'll get 2y is less than or equal to 14 minus x. Divide by 2 on both sides. And we get y is less than or equal to, divide the 2 into both of these. So 14 divided by 2 gives me 7. Minus, this will become 1/2 x, right? There's an invisible 1 here. And then we knock the x off to the side, so we get 1/2 x from that. We're going to graph this as an equation, so we're going to start with the y-intercept of 7. So 1, 2, 3, 4, 5, 6, 7 would be right here. The slope is negative 1/2, so we will go down 1 and to the right 2. All right, so let me pick a different color. So we'll start at 0, 7. We're going to go down 1 to the right 2. Then we're going to connect these 2 points with a solid line because there's an equals to there. So we're going to use a solid line. Right? And so I'm going to connect these 2 points with a solid line. All right. See if I can do this right this time. Okay. All right. So there's my first graph. And let's make a mental note. I forgot to really do this on the last example. But mental note, which direction do I want to shade relative to this line? I want to shade below this line because we have a less than there. We want a region that will be below this line. So keep that in mind. Let's take a look at the second inequality. We have 2x plus y is less than or equal to 16. We'll solve this for y. This is a little bit easier. We subtract 2x from both sides, and that's it. So we'll get y is less than or equal to 16 minus 2x. We're going to graph this as an equation. And this really stinks because I did not really anticipate such a big number here, 16. I didn't leave myself that much room. I might be able to extend the graph and fit it on there. So let me try. Let me try to do that. So I'm going to make this line go up further. All right, so that's the y-axis going up further. And then I'll pick up here from 7. We have 8, 9, 10, 11, 12, 13, 14, 15. I'm trying to keep them evenly spaced out, and I barely can fit it on the screen, but I think we can go with that. So we have the y-intercept is 16, so we'll start from up here. Right, so we have this point at 0, 16. The slope in this case is negative 2, which is like negative 2 over 1. So we're going to go down 2 to the right 1. So down to 14 to the right 1, which puts it right here. And then we're going to connect these 2 points with a straight line. Right, because I said a straight line. That's silly. A solid line is what I meant to say. All lines are straight. That's kind of a joke I make with my students in class when I ask them, what kind of line is this? And they say straight line. And I kind of chuckle at that because all lines are straight. And then I just made the same mistake. All right, so let me try to draw a straight line here. And it's a solid line. And it's going to look something like this. All right, so let's see how far it'll let me go with that. All right. And so we get a line that looks like that. All right. And sorry, I kind of went out of view there for a second, but now it's back. That takes care of the second inequality. And again, let's make a mental note. Which direction do I want to shade relative to the second line? I want to shade below that line as well. So below this first line and below the second line at the same time. Our third inequality is that we want x to be greater than or equal to 0. We're going to graph that as an equation. So I'm going to graph the line x equals 0. We did an example of this earlier. Whenever you have x equals a number, that will be a vertical line. So we cannot solve this for y. We have to leave it the way it is, graph it the best we can, which means it's going to be, I shouldn't say graph it the best we can. We can graph this, but we just do the best we can with it, being unable to solve it for y. So we'll go ahead and graph it as an equation, which is x equals 0. That's going to be a vertical line that passes through 0 on the x-axis, which is this point right here. So we want a vertical line going along the y-axis. And again, we want a solid line. So let's go ahead and do the straight line tool again. And we're going to graph a solid line that is the y-axis. That's going to be my graph. And I just really messed that up here. Let me see if I can fix it. Let's go a little bit back this way. Okay, that looks better. And then we want to decide which direction do we shade for this graph. Because we want x to be greater than 0, we want the points that are to the right of this vertical line. So remember, x being greater than will be to the right, x less than means to the left. So if you can't solve it for y and you have it solved for x instead, you don't ask yourself, do I shade above or below? You ask yourself, do I shade to the left or to the right? And this time we're going to shade to the right because of the greater than. So it's below the first line, below the second line, to the right of the vertical line. And then the last one here is y is greater than or equal to 0. It's already solved for y. So we're going to graph this as an equation. We're going to graph y equals 0, which is a horizontal line that goes through 0 on the y-axis. So if it's a horizontal line passing through 0 on the y-axis, that's just going to be your x-axis. So that is what our line is going to look like for this inequality. So we're going to draw a vertical line, a horizontal line passing through 0 on the y-axis, which means we're going to draw a horizontal line that will just match right up with the x-axis. So it's going to look like that. And for this inequality, we want to shade above this line. So let's find the region that satisfies all 4 of these inequalities. Below the first line, below the second line, to the right of the vertical line, but above the horizontal line, and you get this region right here. So this little region in the middle, which is pretty typically where they place the solution set. Again, it doesn't have to be the region in the middle, but that is where they like to put the answer at. So that would be my solution set for this one. It says find the vertices of any, find the coordinates of any vertices formed, right? And so some of these are kind of obvious, like this one right here, right? There's a lot of vertices in this case. So you're going to have to list a lot of them. This one right here is at 0, 7. So that's one set of vertices that's formed from the vertical line crossing with this diagonal line here. This one, well, I guess, sorry, that's not part of the solution set. So you just want the vertices around the solution set. So just these 4 right here. This one obviously is at 0, 0. This one is not so obvious, but you can find it. It's where this diagonal line crosses the x-axis. And if you can't tell by looking at your graph, you can just go to that equation, which is this one right here, and find the x-intercept. I want to know where it's crossing the x-axis. So I want to find the x-intercept for this, which is where y is equal to 0. So I'm going to plug in 0 for y, and then I'll solve for x. All right, so I'll add 2x to the other side. I get 2x is equal to 16. Divide by 2 on both sides, I get x is equal to 8. And so this point here is at 8, 0. And the most difficult one to find is going to be this one here, this vertex here, where the 2 diagonal lines cross. And you'll have to do this the same way we did the previous example, solving a system of equations. So I'm going to take these 2 inequalities and solve them as a system of equations to find where those 2 lines are going to cross each other. So let me do this real quick to see how well this works. So I already did that. So I'm going to make a little more room below this, and then I will scroll down so that you can see the work I'm doing. All right. Okay, so I'm sorry you kind of lost track. I can still see it on my screen, but you can't see it. So the graph kind of moved up out of the way. Hope that's okay and not too unsettling. But down here, what we're going to do is solve these 2 inequalities as a system of equations. So we have x plus 2y equals 14, and we'll have 2x plus y equals 16. So let's solve this as a system of equations. We have a couple different methods that we could use. Let me make a little more room here for us to work. We could do the elimination method. We could also do the substitution method. So maybe let's practice the substitution method in this case. So to use the substitution method, we have to solve one of the equations for one of the variables. So I'm going to choose to solve the bottom equation for y. That looks like an easy one to do. So I'll subtract the 2x to the other side, and I get, sorry, let's try that again. And I get, oh gosh, I can't draw arrows for anything. I'll get y is equal to 16 minus 2x. And I'll take that equation, plug it into the top equation, the one I haven't used yet, plug that in for y. And so I will get x plus 2 times y, which is 16 minus 2x, equals 14. And then I'll solve this equation for x. So I'll distribute the 2. I'll get x plus 32 minus 4x equals 14. Let's get a little bit more room to work here. I'll combine these like terms. Well, okay. Tried it too soon. Let me undo that. Okay, let's try that. Oh, I accidentally did it again. All right, so we get x minus 4x, which is negative 3x. And then I'll subtract the 32 to the other side. And I'll get 14 minus 32, which is negative 18. So this actually works out nice. I was kind of afraid it was going to be a fraction. But when we go to solve this for x, we divide by negative 3 on both sides, and we get x is equal to 6. All right. And then we take this solution, plug it back in here to find the corresponding value for y. So get y is equal to 16 minus 2 times 6, which is going to be 16 minus 12, which is going to be 4. And so where those two diagonal lines cross will be at 6, 4. And that would be the final vertex. You're going to have to type all of these vertices into a single box on Math Excel. And so it's going to be a string of points separated by commas, which can get a little bit confusing. So just be careful when you're typing that in with your parentheses and your commas that you don't accidentally leave one out or accidentally include one where there shouldn't be one, and then you should be okay. So that concludes section 3.7, which is on solving systems of inequalities.